Aerospace is about reaching further. Further in technology, into space, and into the future. You want to reach further too. You enjoy puzzling, prototyping, and pioneering. You're drawn to complex questions behind how to make aviation and space travel ready for tomorrow. Quieter, safer, faster, and cleaner. You'll join a community of students from all over the world who, just like you, get bright-eyed over anything that flies. Being part of such a diverse international group prepares you for the aerospace world from day one. This industry revolves around teamwork and a global point of view. That's why it's such an advantage when you've already worked during your studies with people from different cultures, with different perspectives, norms, and values. In our hangar and labs, and on site with partner companies, you will work on technological innovation that reaches past aerospace itself. From developing satellites, to improving wind turbines and Formula One materials. That's how you grow into an engineer who helps technology reach further.
Applied Aerospace Live.
And we're live. Space Explorers, welcome to Applied Aerospace Live, episode 9. My name is Erik Laan. I'm a lecturer of space engineering here at Inholland University of Applied Science. And I have together with me on the desk today Promod from the AQUILO rocket team, our AQUILO rocket team. Promod was with us on day one of the Applied Aerospace Live podcast, so he's been like living through the whole Artemis 2 mission, and we're going to look back a bit on the mission. But of course, we all know tomorrow is the big day. So this night at 2 o'clock, there will be a splashdown.
Exactly.
With 4 healthy astronauts, and the mission will be concluded. So, Promod, how do you look back on the last days here?
So I think the first day we talked about the launch itself, and it went pretty successful. So that was the important part, getting there. So that went successful, and of course it was safe. Everything was done safely. And then there was the other key moment, the lunar injection, which was also done properly. And then there was again the moment of blackout in which we couldn't reach the astronauts. But of course, there was nothing concerning, and then we regained connection after the expected time, and now they're heading back. So I think they're almost halfway to the Earth right now. So it should be good. Everything was good till now. So I hope nothing goes wrong. And of course, now the important part is bringing our astronauts back home safely. And also, I think that is also one of the most difficult parts. Making the splashdown properly and entering the Earth orbit properly. So
we're really a bit anxious. I feel a bit anxious about the day, because if you look, for example, at the schedule of the astronauts, the timeline of what they're doing for today is just crew sleep. That's all. And then you look at tomorrow and you see like a long list of things that really need to happen on time, everything on time, to make that splashdown at 8 minutes past 2 in the night, Central European time to happen. And I'm going to watch it. I know I'm looking for a tired weekend, but I will be watching it. But people, space explorers at home, if you have any questions, please put them in the chat. We totally forgot about it yesterday, so this is our time to make up to you. So any questions you will have, feel free to leave your questions in the chat, and Promod and I will try to answer them. So. But we have some standard segments, but also a bit quiet there on those things. So the Nutella thing, well, that kind of happened. But I saw Nutella on Instagram. They put out also like a nice ad, and people were also discussing on internet how much such an ad would have cost if they would really have applied through the proper channels for such an ad, and that's in the millions. And they just got this for free, Nutella. Isn't that beautiful? We're still looking for Nutella sponsoring our show, that we have free Nutella for the rest of the year.
Exactly.
But we'll hope to hear back from them. So also on the toilet, it was a bit quiet. Yeah. I haven't heard any news. Did you?
No, I did not hear any news. But I also heard that there were some lot of leftovers from the previous moon landings on the moon.
Yes, and, exactly. Yes.
That was quite interesting. What could have been left there, right? That's what I think everyone is thinking about right now.
So 200 tons of trash is on the moon.
Exactly.
Result of the Apollo missions. So the landers are there, and like boots that they used on the moon. They left. They wanted to be as light as possible to go back into lunar orbit. There is a nice picture. There's VRT News, also on Instagram, had a news article about it. But also what is interesting for me were all the comments in this Instagram post, which were also claiming, well, the moon landing that did never happen. That's still, with some people, they're still a bit weird in their head, I think, to really think that the moon landings did not happen. But anyway, it does show humans need to be more careful about the environment. I think when we return to the moon, we should not just leave a lot of trash there. And that's certainly for Artemis, I think, a learning point to go for in the future.
That's true.
We can also look at a nice picture that was taken of the astronauts. So we're looking at the crew here as they fly back. One of the recent pictures. So this is the crew flying back to Earth. They went to the moon and back, and hopefully tomorrow we'll see a safe landing in front of the coast of San Diego, so the Pacific coast. And there's some discussion about a trajectory, right? So we looked a bit into that.
So it should be around in a radius of around 100 miles. So that should be the area in which the integrator should land, basically. But it's of course dependent on how the capsule enters the Earth's atmosphere and how its trajectory is based on the angle that it enters. So it all depends on that. But I think here in Europe they are working at their best, and also of course NASA, to manage that and bring the astronauts safely and also recover it as soon as possible. I also heard that the ship vessels for the recovery are already sent out, so
they're waiting already arrival of the crew. And for now, the capsule and the European Service Module are still connected. So this is still flying like this in space, and there will be some moment that this will be detached, and they both get onto a collision course basically with Earth. Well, this thing kind of gets destroyed by the atmosphere because it doesn't have a heat shield. And this one contains the 4 astronauts. And this takes a very special profile through the atmosphere. And it takes about 13 minutes. So it hits the atmosphere at an altitude of 100 kilometers. And then you get this, this plasma formation in front of the capsule, because it's going at 10.5 kilometers per second. It like pressurizes the air in front of it to make it into a plasma, and also that causes then a blackout again. They cannot communicate with the capsule because of the plasma that's surrounding it. So that's basically a cage of Faraday where you cannot get really RF signals through. And this is one of the critical moments. So they need to survive that. But there is also a later phase where they are lower in the atmosphere. There's more air, so you also get convective heat to the capsule. So there is a number of important parts of that trajectory we're looking forward to happening and keeping them safe.
So as you also saw with the Artemis 1 launch, there was also problems with the heat shield, where we saw small parts of the heat shield being gone away, like literally removed. But they concluded that it is not gonna probably happen again. And
they hope so,
They hope so. And then that also was concluded that it was due to the angle that they entered the Earth's atmosphere. So hopefully this time we can get it right to a precise angle, and then we can see our astronauts back home safely.
I'm so really curious for the pictures of the heat shield after, because we've seen the pictures of the heat shields of Artemis 1, and you clearly see like streaks and material that really got broken off the heat shield. And also internally to the Artemis 1 capsule, they also found the titanium structure at some points really got like kind of melted because of heat flowing in there. You don't want that with people inside.
Exactly.
So I'm really curious for those pictures to be shown. But first of all, the astronauts need to be safe, and we look forward to that moment. And tomorrow will be, for the moment, the last episode of Applied Aerospace Live, where we have a colleague from the European Space Agency, Janne Persson. He personally went to see the launch, but he's back now, and he works at the European Space Agency on the Artemis program. So we will together look back, on the hopefully successful landing of the astronauts tomorrow. Again, at 3 o'clock will be the closure for this season. But of course, in the future, we would like to continue, of course, this Applied Aerospace Live channel with other things that are going to happen in the aerospace field, like electric flying, your rocket launch in May. We certainly want to do something with that, with the Applied Aerospace Live channel, and other things that are going to happen here at our terminal in Inholland Delft. So I think it's a moment to look maybe at some questions from the audience that are coming into mission control here. We have Hugo sitting at the desk, connecting all the cameras and all the microphones and all the internet stuff, and making this all happen so you can see us clearly, together with Colin. We have a first question here. So how hot does the heat shield get? And also, why do we have heat shield issues now, while we have successfully done this many times, both from Earth orbit and from the moon? Difficult question.
That's a difficult question.
What's your take on this?
I think it's also because we can't predict them, because we can't simulate these problems on Earth, because we can't reach that much heat, and I don't think we have facilities here.
There's no facility to actually do that test.
So I think so in the atmosphere, of course we know the parameters, of course we know that physics will work, but then we don't precisely know what is going to happen there. So as soon as the capsule enters Earth's atmosphere, there might be something that goes wrong. And I think the heat issues was because of the heat shield issues was because of the weight entered the atmosphere in the previous Artemis mission. But now I think they have an alternate path to enter.
But still they're going to have already a new heat shield designed for Artemis 3. So they've already concluded, we need to do something. But that will again be a test of the new heat shield in Artemis 3. So again, there will be excitement about the heat shield for the next Artemis mission. Also one aspect of this question is also about the Earth orbit and from the moon. Well, if you fly from Earth orbit, you fly from ISS back to the Earth with the Crew Dragon. The velocity you have flying back with the Crew Dragon is about 7.7 kilometers per second. And so this velocity is a bit less than the velocity that our astronauts will see at 2 o'clock tonight. That will have 10.5 kilometers per second. So 3.5 kilometers per second extra of velocity. You might think, well, that's just a little bit higher, but with velocity, as always, things go in the square of the velocity, or in the third law of velocity.
Exactly.
So that's really counting. And the question, with the moon landings in the Apollo area, they did the same thing, of course, with heat shields. But it must be said that the Apollo return capsules were smaller. So it was a little bit easier with smaller capsules. And it was still also experimental. That's the whole what you addressed as well. You're developing something, and you have all the knowledge from theory that it should work, but how do you then actually show it works? Really test it in a real environment? Well, can only be done in the atmosphere at that velocity, which you can do on Earth. So that hopefully answers that question. Next question is, you mentioned the material left on the moon. Should this be cleaned in the future? Does it really affect the rest on the moon? Fair question.
Fair question.
Should it be cleaned?
I think so, definitely.
or is it like they call it also heritage of mankind? This mess that we put there. Look, we did this back in the historical. Look at these boots on the ground. They lie there as they were put there like 50, 60 years ago.
Exactly. I think coming back to the Earth again, we have to be light as possible. So I don't know how it can be achieved, or it will ever be achieved to clean the moon.
Yeah.
But of course, it would be nice. But I don't see it as the most, let's say, the critical thing. That we should concentrate on, because it's of course going to be hard. And right now, going around the moon was. Of course, hard for us. It took us so many years to build these developments, and then to bring the trash back down, it's going to be, I believe, more difficult.
Yeah.
So,
and I think the last point that's raised here: does it really affect the rest on the moon? Well, actually, that's on the moon. The moon is basically a very static body.
Yeah.
Like if you throw away something on the ground on Earth, there is erosion. There is fluids. Things get into the groundwater, like this dispersion of materials into the environment that we consume as well. But on the moon, there is no living creature at all, and there is no transportation of trash to other places. That everything gets polluted.
Yeah.
I still don't think we should pollute the moon, but well, there is no real person having a problem with the trash now, because no one lives there.
Exactly.
But it doesn't mean we should leave our trash there, I think. So really for Artemis, we should clean up.
Yeah.
Our next question here. Artemis 2 will reach nearly Mach 40, faster than any human has ever traveled. Its trajectory and re-entry angle are also unlike anything done before for a moon mission. And the question is...
Just a statement.
Just a statement, yeah. So, yeah, that's a valid statement. So it's a new way of landing stuff from space on Earth. Should Europe join in the new space race with their own reusable rockets? I say yes.
I also say yes.
Yes. No, of course, but that's just thinking out loud that we should do that.
Yeah.
What's your take on that?
Yeah, but of course, it's a lot of work, let's say. Even the Artemis project would have not been feasible without the help of the European capsule. So that's still a big improvement.
This part is all European.
Exactly.
Without it, there were no astronauts flying around the moon.
And still, they are still controlled by European centers here in Europe. And I believe we need to take step-by-step approaches. But maybe one day, of course, we can use a whole European rocket to go to moon. But I think, in my opinion, it will take a bit more of time as this industry is developing every day. But it will take some time for a whole European rocket to go to moon.
Yeah. But if this question alludes to the fact that we should join the new space race for bringing humans into space, I think that's the question. That's what the question is about. I think there's also a cultural difference between the US and Europe, where in Europe we look at space more in a pragmatic way for Earth observation, for satellite telecommunication, for navigation. We see all those valuable assets to help society and every consumer. And for humans in space, we think, well, in Europe, it's nice. Well, I'm excited, but like the general public is more relaxed about it. Whereas in the US, it's more of a cultural thing, going to the next frontier and looking for resources in space, and see it as a place for dominance. You know, there is a more of a cultural thing in the US with respect to space. Crew-rated Ariane? A question mark. Yeah, there's a long story to tell about this. What would you say about Ariane 6 then? Should we?
Why not?
Why not? Yeah, but it costs money.
It costs money.
It costs money, and there has been exercises to make already Ariane 5, the launch that is not operational anymore, to make that man-rated. We had the so-called Hermes spaceplane in the 90s, developed for bringing European astronauts into space, but this was abandoned, this project, the Hermes spaceplane. There's a beautiful book about it by Luc van den Abelen, one of my co-hosts at the BNR Space Cowboys podcast. He wrote a book about that. And now we have Ariane 6. And yes, we can crew rate Ariane 6 and put astronauts on top of this rocket. Yeah, we can. Why not? Let's put some money in there.
Yeah.
Next question on the screen.
No more questions so far.
Oh, no more question. Well, there is a question here from the audience.
So I was wondering, like, when any object coming from outer space toward Earth at a high velocity, it's burning at impact with the atmosphere. So is such a danger applicable to the Artemis while in return to Earth?
Yeah, so the question is, the capsule will hit the Earth and hit the atmosphere.
Yeah.
Is that...
Like, is it having a too high speed that it puts it in a danger of burning?
No, there is no... The question is there a risk that the speed is too high?
Yeah.
Yeah, so that risk is zero, because we perfectly understand how objects fly in space. We can predict velocities and locations of spacecraft almost to the like in this case to the meter accurate, or the meter per second accurate. So there is no risk that suddenly the capsule is 1 kilometer per second faster than we thought of. So yeah, this is no risk at all. I mean, the main risk is just uncertainties in what kind of the atmosphere is a fluctuating thing, of course. It's not a fixed thing. Sometimes it has more pressure and other constituents, and there is activity of the solar irradiance, and there is all kinds of weather systems that are also affecting things. So it's a dynamic system, and so those introduce some uncertainties to this re-entry.
I have another question, please.
Okay, last question from the audience, and then we'll wrap up.
Okay, thanks. So the 4 people who are involved in this mission to Moon, will they be the same people in the 2 years later mission, or maybe Europeans also involved?
Yeah, so the question is that the 4 astronauts that are now on Artemis 2, will they be part of future Artemis missions? Well, those crews have not been known yet, but they will be selected in the next years. My expectation is that some of these crew members will get back if the program continues in Artemis 6, 7, 8. But we will first see other crews, and also European astronauts will join. Like, for example, there is a Canadian astronaut, and Canada is a so-called associated member of the European Space Agency. Although it's not a European country, it has a bond with the European Space Agency. So it's kind of a European Space Agency astronaut. Because Canada also has a contribution to Artemis, like the European countries in the European Space Agency. But I expect on the next Artemis missions to be, for example, a German astronaut or a French, because they have a big contribution in the European Space Agency programs, and we'll see astronauts from Germany and France specifically.
Thanks.
Okay, with that, I'm going to thank the audience. I'm going to thank the people behind the desk, Hugo and Colin. Promod, thank you again for joining the show.
It was a pleasure.
And we'll see us tomorrow at 3 o'clock.
Yep.
May the force be with you. Okay.